Okay, so this question here was not done all that well, and I think I know why it is. Okay, it's almost because the first part of it especially seems like it's too easy to be a mark in a GCSE. So this one is about thermal energy and specifically infrared radiation. There's some quite simple ones and you need to recognise when there are simple questions, and there's a more difficult one about an equilibrium between the rate of heat transfers. Let's figure out why it is not too easy and why we should just be able to state why the water gets hotter in the first 200 minutes. If you see that command word state, you're expecting to be something that you could just reel off. You don't really have to think about too much, it's just something simple. A student used energy from the sun to heat the cold water, okay, so there's some energy from the sun. She puts cold water into a black teapot and measures the temperature of the water. The infrared rays from the sun are coming in, they're being absorbed by the black teapot, they're containing the water and the thermometer, so that's measuring the temperature. And here's the temperature, it rises and rises and rises until it gets to a kind of equilibrium point. Okay, so state why the water gets hotter in the first 200 minutes. Well, this is as simple as saying that the teapot, the black teapot, absorbs infrared energy from the sun. And that seems far too simple to get a mark. But notice, you're told that infrared waves coming on, you're told something about energy from the sun, but you're never told that the black teapot absorbs the energy from the sun. So if you've got absorbs heat or absorbs energy from the sun, you get a mark. You were not told that it's absorbed there. It could be that you misunderstand and think that the black teapot reflects the energy from the sun. It's just testing out something quite simple, that black is a good absorber of infrared. So explain though, so a little bit more difficult, why the black teapot remains a steady temperature after 200 minutes. It's an idea of equilibrium, and that is the first law of thermodynamics, that things will reach an equilibrium position where they will be at the same temperature. But the problem with this part is that it's not going to be the water that is the same temperature as the surrounding air, because the air is not going to be absorbing the infrared waves from the sun. So there's an equilibrium between two other things. There's an equilibrium between the rate of absorbing the energy and the rate of emitting the energy. So this is asking you really to apply a bit of knowledge. It's asking you to apply the knowledge that you know that the black is a good absorber and a good emitter of infrared radiation. Okay, so that's our first thing to get down. We get a mark for each of those. And it is very important that you get this word rate into this to get this last mark. So you get a mark for saying they absorb and a mark for saying that they emit. So you have to link those 2 points to get these marks though. And there is an equilibrium between the rate of absorption and the rate of emission of infrared radiation. Okay, hope that one helps you out. Just 4 marks really, a bit more straightforward than they maybe seemed at first. Okay, this is Guerrilla Physics. That was an OCR Gateway paper, second higher tier paper question, and I hope that was useful to you. We're all about you understanding your physics more, so you get more confident, enjoy it more, and do better in your exam.